Hello guys, welcome to today's lesson. Here we have a problem which says we have to evaluate, or in other words now, we need to find the limit point for what we have below here. So here's the solution. So for what we have, if we plugged in, so we have limit of x and y as they approach 0. Both of them are approaching 0. So for the function, so if we are to substitute directly from what you have here, we're going to have a situation of 0 over 0. So, and we know to say 0 over 0, it is undefined. So this is undefined. So we need to look for a way that is actually going to help us find the limit points. So here's a clue. So let's do this. Let's approach the point 0, 0 along the line all right, so we're going to approach this point along this line. So this gives us the limit of x as it approaches 0 for x, and then where there is y, we substitute that value mx, and also x squared over mx squared. So that's what we have now. So we can write this nicely, limit of x. So we've left out y because we no longer have y in this expression now. So this one, it gives us x squared m over x squared. So we can factor out x squared here, this x squared, and also this side is x squared. So we have x squared, then what remains this side is 1 plus m squared, like that. Okay, so after this point, or after this step, now what you need to do, you can cancel out this x and that. So we're going to have m over 1 plus m squared. All right, so now after having found this expression now, all right, so after having this expression now, we know to say that m here stands for the gradient, which we can conclude to say m is from the set of real numbers. So m can be any real number. So now we need to try and see if what we get is consistent when it comes to limits. So the first one, we say when m is equals to 1. So you can pick any random values of m as long as they are from the set of real numbers. So when m is equals to 1, what do we have? This actually gives us a situation of, so we're going to substitute where this m, we're going to have 1 over 1 plus 1 squared. So this becomes 1 over 2. Okay, so now this becomes the limit point for the whole thing when m is equals to 1. Again, we can try and check using a different value for m. So when m is equals to 2, what do we have? So now it is going to be 2 plus like this. So this becomes 2 over, so this is 4, 5. So this is another limit point. So we now have two different limit points for the same equation. So now if we try the last one, so that we verify something here, when m is equals to, it could be any other value that you are comfortable with. So you're going to have 3 over, this is going to be 10, of which this is going to be something like 0.3. So clearly, so we can say, we can write clearly this xy over xy over x squared plus y squared. So we can say clearly this does not exist, or we can still say it doesn't have a limit point, because in as much as you're approaching 0, 0, we get different values